Welcome back. Today we're going to be learning about the Pythagorean theorem and its converse. That's going to be a new term. It's a vocabulary term that I have posted on your Canvas page so you can go back and take a look at it if you need to. Now, we're going to start off with a little bit of review. So I want you to pause the video and I want you to solve these two problems here, and then I want you to scroll down and solve those two problems there. So go ahead and take a minute and do both of those. All right, let's take a look at them together. First off, for this one, we're going to undo addition and subtraction to isolate my variables. So I'm going to subtract 7 from both sides. When I do that, those 7s are going to zero out, leaving x squared is now equal to, and 43 minus 7, that's going to be 36. Next, I don't care what x squared is, I want to know what x is, so I'm going to take the square root of both sides. The square root of x squared, that's going to give me x. The square root of 36 is going to give me 6. How'd you do on that one? Now for the next one, we're going to start the same way. We're going to isolate the variable, undoing addition and subtraction by subtracting 64. Now, I should point out that this is a subtracting 64 because it is a positive 64 right there. This other plus sign here, that belongs to the x, so be careful not to get confused by that. The 64s are going to zero each other out, leaving x squared is equal to 100. Once again, I have to take the square root of both sides, so the square root on the left and the square root on the right. If I do it on one side, I have to do it on the other. The square root of x squared is x, and the square root of 100, that's going to be 10. Scrolling down for the next part. Now for this one, we're going to be substituting in some values for a, b, and c. A is going to be 12, so that's going to become 12 squared. B is going to be 5, so that's going to become 5 squared. 12 squared is going to be 12 times 12, or 144. 5 squared, that's 5 times 5, which is 25, and that's going to give us a final answer of 169. Now, over here, c squared, that's going to be 13 squared, minus b squared, that's going to become 5 squared. Well, c squared, 13 times 13 is, 169. Have we seen that value someplace before? And then we're going to subtract the 25 from it. And let's see, I'm thinking we've seen that value someplace before too. And then when we do, what do you think we're going to end up getting? Well, we're going to end up getting the 144 that we ended up seeing right here. How about that? Now that's all just to kind of get your mind working and thinking and remembering some stuff about the Pythagorean theorem that we used yesterday and how to isolate variables, how to take the square root on both sides and things like that. From here, we are going to watch a video of the Wizard of Oz, and we're going to see just how smart Scarecrow actually is.
Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
Ph.D.?
That's Doctor of Thinkology.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! Rapture! I've got a brain!
Oh, but does he have a brain? Did you catch his mistake? Let's go back and look at it one more time. So I'm going to go back right about here. Listen close.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy!
Now, I want you to take and think about what he said there, what he said that makes sense, and what he said that's wrong. And there's a couple of issues in what he said. Go ahead and work on that right now. So did you figure out Scarecrow's mistakes? Here's what he said. He said the sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Lots of issues in here. First issue is we're going to take out the word root on both of those. So the sum of the squares of, and it's not any two sides, is it? It's going to be the two shortest sides of any, is it an isosceles triangle? Nope, it is a right triangle, is equal to the square of its remaining side, which is also known as a hypotenuse. So maybe Scarecrow doesn't have a brain after all. I mean, I'm just saying that PhD in thinkology just I'm not seeing it very well represented here. He's not thinking too good on that. So let's take now, we're going to scroll down here a little bit, and we're going to do our take notice, and we're going to say it doesn't really matter what leg you plug in for what? For A and B. What matters is that C is going to be the hypotenuse, and the hypotenuse is always located opposite the right angle. Very important concepts for you to remember and focus on as you work through these problems. Scrolling down from there, we're going to say determine if you need to find the length of a leg or a hypotenuse. And then from there, we're going to use the Pythagorean theorem to find the length of the missing side. And finally, we're going to round our answers to the nearest tenth. Now, we're going to work number 1 and number 3 together, and you're going to work number 2 and number 4 on your own. Now, for this one, we're going to be looking for the hypotenuse, which is side C. The very first thing you have to write on each and every problem is your formula. A squared plus B squared is equal to C squared. If you don't write your formula, you will have done your homework just for fun. From there, I'm going to call this side A and this side B. It doesn't really matter which one is which. So that's going to give me 3 squared plus 7 squared is equal to C squared. 3 squared, that's going to be 9. 7 squared, that's going to equal to 49 is equal to C squared. We're going to add 9 to 49, and we're going to get 58 is equal to C squared. From here, of course, we have to take the square root of both sides. The square root of C squared is easy. That's just going to end up being C. And that's going to equal to, now the square root of 58, not so easy. That's an imperfect square, so we're going to use our calculator, and we're going to round that one to about 7.6. So we can take the equal signs, turn them into the squiggly about signs, and we're going to say that that is going to be about 7.6. Now, we're going to come back and let you do number 2 in a minute, but on this one, we want to look at it, and what do we have? We have the side opposite the right angle, so we have C, and we're just go ahead and call this side B, and we're going to look for A. So we're going to start off by writing our formula. A squared plus B squared is equal to C squared, where A squared we're looking for, B is going to be 6, and this time they gave us units, so we've got to carry our units, and this part's important, folks. Pay attention. I put the entire thing in parentheses because we're not just squaring the 6. We're squaring everything B is, which is 6 and feet. We're going to do the same thing for the C. Everything it is 10 feet. It goes in parentheses, and we're going to square it. So that's going to leave me with A squared plus 6 times 6 is 36, and feet times feet is feet squared. Now my parentheses are gone. Equals 10 times 10 is 100. Feet times feet is feet squared. Now we're going to isolate our variable by subtracting 36 feet squared on both sides. Whoops. 36 feet squared and minus 36 feet squared. When I do that, these are going to zero out, leaving A squared is equal to, and that's going to leave us with 64 feet squared. Now, once again, we're going to take the square root of both sides, here and here, And that's going to give us the square root of a squared is just a. The square root of 64, that's going to be 8. And the square root of feet squared, it's the first time we've done that. The square root of feet squared is just going to be feet for your answer. You go ahead and pause the video and work on number 2 and number 4 on your own. All right, here's the answer key for number 2. Hopefully you got the correct answer. You're looking for a leg, so your answer should have been 23.2. And then here's going to be the answer key for, they didn't carry their units all the way through like they should have. You really need to be carrying your units all the way through. I'm going to expect you to do that just like I did in the example. In the end, the final answer should have been 19.4 miles, and they were looking for side C, the hypotenuse. And now it's time for us to move into the converse concept. The converse of the Pythagorean theorem is going to start off, well, we need to first learn a few more things in our take notice here. It says that given 3 side lengths, determine whether they would form a right triangle, and recall that side C is always going to be the longest side. So it says that if c squared is equal to a squared plus b squared, then the measure of angle C is going to equal to 90 degrees, meaning it is going to be a right, whoop, I didn't spell that right triangle. If c squared is greater than a squared plus b squared, then the measure of angle C is going to be greater than 90 degrees, meaning that it is an obtuse triangle. And if c squared is less than the sum of a squared and b squared, then the measure of angle C is going to be less than 90 degrees, making it an acute triangle. Now, this is what you're supposed to get out of this. If it is a right triangle, the sum of a squared and b squared will always equal to c squared. And what do we know about c squared? It's always going to be the longest side. So what we need to do is we need to take these 3 problems here and find out whether or not they form a right triangle. We have the longest side is right here, so we're going to call that side C, I'm going to call that side A, and I'm going to call that side B. So my formula, a squared plus b squared is equal to c squared. From here, we're going to take and plug in what we know. I've got 18 centimeters, all squared in parentheses, plus 9.6 centimeters, all squared in parentheses. I can do better than that. Should equal to 20.1 centimeters, all squared in parentheses, if I did this right. So let's, if it is a right triangle, I should say. So let's start off with 18. So I'm going to take and say 18 times 18 is equal to 324. So that's going to give me 324 centimeters squared, plus, and I'm going to have 9.6 plus 9.6, and that's going to give me, not plus, it should be times. Let's try again. 9.6 times 9.6 is going to give me 92.16. So 92.16 centimeters squared is going to equal to, and then I'm going to have 20.1 plus 20, not plus, dang it. Let's try that again. We'll do 20.1 times 20.1 is going to equal to 404.1 centimeters squared. Now, if I add these 2 together, they should equal what's over here. But I can just look at those numbers and tell you that they're not going to. If I took 324, and added to it 92.16, I'm going to end up getting 416.16 centimeters squared, which is not equal to, put that line in there, 404.1 centimeters squared. So the answer is going to be no, that is not going to be a right triangle. In this case, the value of the 2 of them squared is greater than the c squared, so that means it's actually going to be an obtuse triangle. Now you pause the video and do number 2 on your own. So for number 2, my longest side is going to be this one, so that's going to be my C. I'm going to call that my A. I'm going to call this my B. So that should give me 28.6 inches in parentheses all squared plus 4.8 inches in parentheses all squared should equal to 29 inches in parentheses all squared. Grab up our handy dandy calculator, and that's going to give us 28.6 times 28.6 is going to be 817 and 96 hundredths, 817.96 inches squared, plus I'm going to have 4.8 times 4.8, that's going to equal to 23 and 4 hundredths inches squared, and then we're going to have 29 times 29, that's going to be 841 inches squared. Now, if these two on the left add up to equal this one on the right, then it is going to be a right triangle. And guess what? They do. When I add those two together, I'm going to get 841 inches squared on the left, which is equal to 841 inches squared on the right. So the answer is yes, this one is going to be a right triangle. Now for the very last one here, they give us a kind of tricky problem. They say the triangle has a perimeter of 25 centimeters, and to determine whether or not it's going to be a right triangle. Well, let's start off by drawing it, and I'm going to take and draw kind of like this. And I'm going to say that we have one 7 centimeter side and one 8 centimeter side, and then we have side C over here that we don't really know. But we know that whatever 7 plus 8 plus C is going to equal to 25. So 7 plus 8 is going to equal to 15, and then 25 minus 15 is going to equal to 10. So side C, or the longer side, is going to equal to 10, but we want to find out, is it going to be a right triangle? So we're going to take and plug in our formula. A squared plus B squared is equal to C squared. And then I'm going to take 7 centimeters all squared plus 8 centimeters all squared equals 10 centimeters all squared. 7 times 7 is 49. Centimeter times centimeter is centimeter squared. 8 times 8 is 64. It is not going to work. Centimeter squared is equal to 100 centimeters squared. When I add 49 to 64, I think it's going to end up being 105 centimeters squared, which does not equal to 100 centimeters squared. So the answer is going to be no. It is not a right triangle. Now, your homework assignment today is to do the exit ticket. Now, once again, the exit ticket is the same thing twice because they created it where I could print it out and cut it up and hand it out, but we're not going to do that. You're going to work these two problems, just two little bitty problems, on your own, and you're going to turn those two problems in for homework so I can see if you understand what you're doing. Tomorrow, we'll come back and do the second half of this lesson. Be sure to bring me any questions you have, and I will look forward to seeing you in class tomorrow.